So hello student friends, again I welcome you all to this 22nd lecture of digital electronics. In the last lecture we have discussed the working of this AND gate, right? And we concluded the last lecture saying that we'll see this circuit of AND gate using switches. Okay. Initially we'll try to understand its working with help of switches, and then we can replace this switch with transistor or diode, right? But first let us try to understand how with simple switch, the switch which we are using in our house, just to switch on the fan, switch off the fan, that type of switch, right? Just to make things very simple and clear for you, and then we can just jump for transistor or diode. Now let us quickly recall this truth table of AND gate. So if I have two inputs 0 0 0 1 1 0 1 1, okay, the expression for AND gate is y equal to AB, right? So 0 0 is 0, 0 1 is 0, 1 0 is 0, 1 1 is 1, just based on that statement. So if any of the input is 0, output is 0. If all the inputs are 1, output is 1, right? Now just saying something, so this AND gate will not work. We have to actually form the circuit of that. Physical circuit you should have there, right? It's like just saying the compiler that please tell me whether my entered number is even or odd will not work. You have to actually write the code for that, and you have to compile and execute that code. Okay, then only by entering the input number, the computer or the compiler will give you the result. Okay, so same way, just saying AND gate will not work, we have to actually look for its internal circuit, right? Now here also you need to apply the logic. How should I place my switches such that I will get the function of AND gate? ठीक है, तो कैसे स्विच को हम कैसे प्लेस कर सकते हैं, स्विच पोजीशन कैसा होना चाहिए इज वेरी इंपॉर्टेंट. दैट इज द पार्ट ऑफ लॉजिक हियर, राइट? सो विदाउट much wasting much time, I just form the circuit for that, and it's very simple, right? So consider okay, and this is my LED or this is my bulb. Okay, so this is input. Now since this is digital electronics, it operates on 5 volt DC. Let us consider, or the battery cell, you have just inserted, or you have here the battery cell. Okay, and these are our two switches. So this is A and this is B. Now why two switches? Because we are considering this AND gate as two input AND gate. Okay, so let us consider again the truth table. So this is 0 0 0 1 1 0 1 1. Now as I said, 0 means off and 1 means on, right? So let us try this combination. So 0 means off, the switch is off, and this switch is off. Now will the current from this battery flow to this side? No, because here we have open circuit, right? So current will not flow and this LED will not glow. Okay, this LED is off, hence the output is 0 or off, right? Now in this is first case. In second case, A is 0, so this is A, this is B. A is 0 means this is open switch, right? Switch is not closed, open switch, and B is closed. So consider this B is closed. Okay, still we have open circuit here. Now will the current flow from this point, from this battery to this LED? No, our LED is still off, means 0. Okay, this is another case. Another case, now in this case it's opposite. This A switch is closed and B is open, right? Just imagine that this B switch is now open. Now will there be any current flow from this point to this point? No, because now we have open circuit at point B or at switch B. Still our LED or this bulb is off, means 0. Right? This is third condition and this is fourth condition or fourth combination. So have you seen, I have just tried these combinations, right? So 1 1. Now both switches are closed. Now when both switches are closed, this circuit is completed in this way and current starts flowing through this way. This is current I and our LED now glows. Okay, so LED is on. On means 1. So is it the same truth table that we have studied? Yes. So when any of the input is 0, output is 0. You can see this 0 output is 0, 0 output is 0, 0 output is 0. And if all the inputs are 1, output is 1. Perfect. Okay. So this is how this AND gate can be constructed with help of switches. This switch. And now you can go into this more complex of using transistors. So instead of this switch, I can use transistor 1 or diode 1. And instead of this switch, I can use again transistor 2 or diode 2. Okay, so one thing you need to observe here, that for the AND gate, these switches are in series. They are in series, right? So if I have 3 inputs, I will have one more switch here. So A, B, and consider this one C. But for the circuit to have AND gate operation, the switches must always be in series. Okay, so this is what we mean as the circuit, gate circuit. I already mentioned that it is a circuit which has one or more than one inputs and only one output. Okay, I hope that this concept is clear for you, right? Let us go for the next gate, that is OR gate. OR gate. OR gate means किंवा. I can say हे किंवा ते, this or that. So दोन्ही पैकी एक जरी असेल तरी ओके आहे, दोन्ही असेल तर वेल अँड गुड, पण दोन्ही पैकी एक जरी असेल तरी आउटपुट you will get. Okay, so this is called logical addition. logical addition. Okay, I am not talking about binary addition. No, it's not binary addition, it is logical addition. Okay, we'll see while studying the truth table. Okay, so first is circuit symbol. Again we are considering two input AND gate OR gate, two input. So circuit symbol, now here you need to have some this curve. It takes this type of curve. This is A, this is B, and this is Y. Right? Its logical expression will be Y is equal to A or B. Okay, if we are considering two inputs. Now this, since it is logical addition, it is represented with help of plus sign. This OR gate is represented with help of plus sign, you have to remember. So the logical expression, now I can write A plus B, where this plus indicates that it is OR gate. It is not addition, binary addition, it is logical addition here. Okay, which represents the operation of OR gate. So again, this third part is truth table. Okay, so we can construct truth table very quickly. So this is A, bear me for my this table. In the last I used the scale, but here I am just drawing the freehand sketch. Okay, and you can say serial number or decimal number, and this is output Y. Okay, so for two input AND gate we have 2 raised to 2 is 4. Again 4 combinations starting from 0, 1, 2, 3. Right, so that becomes 0, 0, 0, 1, 1, 0, 1, 1. Right, so all the time you will have this combination itself when we are considering a two input AND gate or two input digital circuit. Okay, now since this is logical addition, now what I mean to say is logical addition, we have seen here this or this, म्हणजे दोन्हीपैकी एक जरी असेल तरी sufficient. Okay, so here 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. It's not 2. So this is not binary addition. This is logical addition. You have to remember very carefully, you have to remember for this OR gate. So that is what हे किंवा हे आहे ना, मग आउटपुट आहे, हे आहे एक तरी आहे ना, आउटपुट आहे. दोन्हीपैकी दोन्ही आहेत पण कमीत कमी एक आहे, आउटपुट आहे. इथे काहीच नाही आहे, आउटपुट नाही आहे. Right, so this is the truth table for OR gate. Right, 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. आता त्यात स्टेटमेंट कसं येऊ शकतं, लॉजिकल स्टेटमेंट. हाऊ वी कॅन फाइंड or how we can create logical statement. Now we can create logical statement for 0 or 1. याच्यात जास्त कोणतं आहे, 1 आहे. मग 1 साठी आपण काय करू शकतो, if any of the input is 1 then output is 1. वनला आपण एका ह्याच्यामध्येच ट्रू असंही म्हणू शकतो किंवा ऑन असंही म्हणू शकतो, राईट. झिरोच्या ह्याच्यात इफ ऑल सगळेच इनपुट जर झिरो असतील, इफ ऑल द इनपुट्स आर झिरो then the output is 0, right? So we are talking this for OR gate, right? I hope these concepts are clear for you. Okay, now I leave you for this assignment. Try for this 3 input OR gate and OR gate using switches. OR gate using switches, right? So you can try for both of these. Just now, before a while, we have discussed this circuit for AND gate using switches, right? Similarly, you can try this circuit for OR gate using switches, and you need to verify with help of this truth table. So that is what we did here. Okay, all right. So this is about OR gate. I can very quickly cover this NOT gate. So third form of basic gate is NOT gate. NOT gate. Okay. So we have seen 1's complement, where 1 becomes 0 and 0 becomes 1. So NOT gate is also called as inverter, because it inverts the input to its opposite. Now if you look at the definition, we have a gate which has one or more than one input. Okay, so NOT gate ही एक ऐसा गेट है जिसको सिर्फ एक ही इनपुट है. NOT gate has the only gate that has one input is this NOT gate. Okay, so the symbol for NOT gate is this way, a triangle and a circle. Now this small circle is called bubble, right? This input you can say any you can say A, right? And in digital term, the invert of or output of NOT gate is called as A bar, right? So if you have 1, then it will give you 0, 1. If you provide 1, so 1 bar means 0, and if you use 0, it will give you 1. So if you here provide 0, 0 bar means 1. So it simply inverts the input to the opposite case, right? So that is why it is called as inverter or complement, but generally it is called as inverter or simply NOT gate, right? And this bubble, this is very important here, right? So this is a symbol for the NOT gate. This is the expression. So expression we can say y is equal to A bar. This is a truth table where this is input and this is output. So if input is 1, output is 0. If input is 0, output is 1, right? And the logical statement is very simple. The NOT gate complements or inverts its input. Okay, now here you can try for this circuit not gate circuit using switches. Now you will really enjoy this assignment, this work, because when your switch is off, your LED is on, right? So switch is off, LED is on, म्हणजे बटन बंद आहे आणि तरी लाईट चालू आहे, असं सर्किट अरेंजमेंट तुम्हाला आता तयार करायचं आहे. कशासाठी? नॉट गेटसाठी. ओके, so you can try for this, and you can send me on my personal WhatsApp, right? Okay, so in the next lecture we will go for the derived types of gates, that is universal gates. Okay, and we'll see why they are called as derived, and again why they are called as universal, right? So that is all for this lecture. Thank you and have a nice time.